And now that we know what YAML configuration files are and what they are used for, let's see how we can create a new file that contains the configuration parameter for the ros2 control library for our robot. Since this configuration file will contain specific parameters for configuring the control system of our robot, let's create it inside a new package within our workspace. So let's open a new terminal, let's go to the workspace, and let's go to the source folder, in which, as you remember, there are all the packages that we have created so far. And here let's create a new package with the command ros2 package create, and let's use as build type, let's use amend cmake, as we are going to use both. So we are going to create Python and C++ code in this package, and let's call it bumperbot controller. So let's press enter in order to create this new package. And now, as you can see here, we have the bumperbot controller package. Now we can go back to our workspace and we can build it in order to compile here our new package that we have created. Now let's move on to go to Visual Studio Code. And so now within this new package, so within the bumperbot controller, we can start by creating a new configuration file. So here, let's create a new folder, and let's call this one config, so the config folder, and within this folder, let's create a new file called bumperbot controllers.yaml. Perfect. And as I mentioned in the theoretical lessons on configuration files, a YAML file always starts with the name of the node to which the configuration parameter refer. So in our case, we are configuring the node that is called controller manager. So the controller manager, and for this node we want to set the ros parameters. So here it's the lowercase. Perfect. So as I said, we are setting the ros parameters, and now after these two commands we can actually set the parameters of this node, starting with the update rate, and we can set this one to 100, so to 100 Hertz. So actually our controller will be executed 10 times per second. And then we can also set the use sim time parameter, and for the moment let's set this one to true, as we are only going to use for the moment this controller configuration only for the simulated robot. And then also we can add the actual names of the controllers that we want to load and that we want to use for our robot. So let's set the first one, that is the joint state broadcaster. And now for this controller we need to set its type. And so the type of this controller, actually this module, is responsible for publishing the current state of each joint of the robot into a topic, making it available and so usable by other nodes that needs to know the current position of the robot's wheels. So we can use actually the joint state. So from the joint state broadcaster package, we want the joint state broadcaster class. So we are starting actually this controller here. Now let's also declare another controller that is a simple velocity controller for the moment for actuating our robot wheels. So let's call it simple velocity controller. And now again, let's set its type and the type of this controller. So we want to use a velocity controller as we want to send velocity commands to the robot wheels. And now we can use a velocity controller that is already implemented into the velocity controllers package, and that is called joint group velocity controller. So for the moment we are just going to start this one here, so this velocity controller here. So far, however, we have only indicated to the controller manager the names and the types of the controller that it should load. Now we also need to configure the parameters of this controller. Specifically, we need to configure the parameters of the simple velocity controller. So actually we can do this in this same YAML file. So we can go to the bottom. So let's configure the simple velocity controller, and also in this case this is a ros2 node, so let's configure it as a ros2 node. So let's configure the ros parameters of this node, starting with the joints. So here we want to configure which are the joints that we want to actuate with this velocity controller, and these are the wheel left joint, and also we have the wheel right joint. Perfect. And with this, our configuration file for the controller manager node and for the simple velocity controller is completed, and so we can start using it. However, we will come back to modify this file in order to load different controllers. For the moment, let's just proceed to install it, so to install this file, so in order to inform the compiler about the existence of this file here, and in general the existence of the config folder within the BumperBot controller package. So let's go into the CMake list that is within the BumperBot controller package. Let's remove all the commented lines, we are not going to need them for the moment. Perfect. And here, so after the find package, let's add a new install instruction, and so we want to install the directory, so the folder that is called config, and we want to install this one in the destination, that is the share folder, and then within the subfolder that is called as the package itself, so BumperBot controller. And instead of using directly the name of the package, we can also use the variable project name. Let's save this file, and we have also to remember that now we want to insert this configuration here, so we want the controller, the ros2 controller, to start using this configuration here. So actually we need to set this one into the URDF model of the robot. In fact, as you might remember, in the BumperBot description, and then in the URDF and in the BumperBot gazebo, so here when we have started the gazebo ros2 control plugin, we have also set some parameters, but for the moment these were just empty parameters because we didn't have this file here, so it wasn't created. Now that we have it, we can start using it. And so let's use the $sign in order to find the BumperBot controller package, and from the BumperBot controller we want to access to the config folder, and from the config folder we want to load the BumperBot controllers.yaml file. Perfect. And actually we want to load this YAML file if we are using the ignition, so if we are on ros2 humble, or also if we are on newer version. So here also we want to load the same controller configuration. Perfect. So we can save also this file. And finally, we need one last change. This time we need to change in the launch folder, we need to change the gazebo.launch.py file. And actually the change that you are going to need is in order to set this argument here. So is in order to set the isIgnition parameter in order to load the proper ros2 control version, so the proper plugin. In order to do so, if we open this launch file here, now we can go here at the top of this file, and here let's declare a new variable that is called ros_distro, and which we are going to insert the current, so we are going to read the current ROS distribution that you are using. And in order to do so, we can simply read an environmental variable that is automatically set on Linux that is called ros_distro. So let's use the os environ, so this is a Python function that lets us read the ros_distro environmental variable. So from now on, this variable here, so the ros_distro variable, will contain a string whose value depends on the ros2 distribution that you installed on your PC. Now we want to use this variable in order to decide which ros2 control plugin to use. In fact, we want to set the isIgnition variable, so we want to set this one to true if the ROS distro that you are using is humble. Otherwise, this will be set to false. So, going back here, if you are on ros2 humble, this one will be set to true, and so you will load this plugin here. Otherwise, it will load this plugin here. Perfect. So let's go back here, and now actually, if you consider the advice of Visual Studio Code, this is telling you that this variable is still unused, so we still need to use this variable, and actually we need to pass this one to the Xacro, so to the URDF model. So what we want to do now is to use this variable, so this one that we have created, and set it here, so in order to update the value of this argument here. In order to do so, back in the launch file, where we are loading the URDF file is here. So here is actually where we are using the Xacro command in order to load our model, so our URDF model, and actually here. So let's organize this one a little bit better. So here we are using the Xacro command and then the model. Perfect. And here after the launch configuration, so after using the Xacro command and having passed the full directory to our URDF model, we want to set the isIgnition argument. So we want to set this one and the value. So we want to set the value of this argument. That is the isIgnition variable that we have just created, and that's it. So actually with just this instruction, we are setting the isIgnition argument, so we are setting the value of this one to either true or to false, so that we can load the proper ros2 control plugin. And that's it. So we can also save this file, and we can finally verify that we have properly configured everything. So let's go to the terminal, let's build it again. Perfect. Now let's open a new window of the terminal. Let's make this one a little bit bigger. And again, we can source the file setup.bash that is in the install folder. And here, let's start just the gazebo simulation with ros2 launch. And from the bumperbot description package, let's start the gazebo.launch.py. So let's press enter. This will start gazebo. Let's spawn our robot within the empty world. So here we have it, our robot is perfectly spawned, and now if we open the terminal, we should see a log indicating whether the ros2 control plugin has been properly loaded. So if we go above, we can already see it. So perfect. Here we can see that the gazebo sim ros2 control plugin has been properly loaded, and so here we can also see that these are the joints, so this is the command interface that we have set to be only a velocity command interface. This is the state interface that we have set to be both a position interface and a velocity interface. And in general, this confirms us so that also the controller manager has been properly loaded, and most importantly, that the gazebo ros2 control plugin is active, is available, and so we will see how in the following lessons we're going to use this plugin in order to actuate, in order to move the simulated wheels of our robot.